When most people think of green energy, they probably think of this, or this. But America's biggest source of green energy, by far, is this. Today, there are 104 nuclear reactors in 31 states, producing more than 800 billion kilowatts of electricity each year, without emitting greenhouse gases. Those nuclear reactors run on uranium. A single uranium fuel pellet less than an inch long generates about as much energy as 3 42-gallon barrels of oil, or 1 ton of coal.
The thing about nuclear energy, it's an amazingly compact source of energy. If you took all the electricity that I used in my lifetime, the waste generated by that amount of electricity would fit in one Coke can.
At Argonne National Laboratory, we're working on finding ingenious new ways to make nuclear energy even greener by recycling nuclear fuel. Recycling nuclear fuel is a tricky business that requires lots of high-level engineering and chemistry. Nuclear power stations use fuel rods of concentrated uranium to generate heat, which is used to boil water, which creates high-pressure steam, which turns turbines that generate electricity 24 hours a day, 7 days a week. The rods generate energy by transforming some of the uranium into different elements. Over time, those waste products, called fission products, start to build up. So after about 4 years, it's time to replace those rods with brand new ones to keep the plant running at top efficiency, which led Argonne scientists to a challenge. What can we do with those old fuel rods? About 4% is fission products, which are truly unusable. But the rest of it, about 95% uranium and 1% transuranic elements, can still be used for fuel. But since the fission products are thoroughly mixed with the reusable uranium, we need chemistry to separate them out. So the scientists at Argonne National Laboratory are working on ways to recycle the material in those used fuel rods. The process of separating the useful stuff from the trash is called pyroprocessing, a nifty technology invented by Argonne scientists. Pyroprocessing uses electrical currents and chemical reactions to separate the useful materials from the waste. The main part of this recycle process is being tested here.
This is a large argon inert atmosphere glove box. It allows us to work with uranium metal and large pieces of electrorefining equipment to test operations efficiency.
After chopping the fuel rods into small pieces, you submerge them in a vat of molten salts. When you run an electric current through the vat, the uranium and transuranics separate out and forms crystals on the electrodes. Then we form new rods out of the newly recycled fuel and put them into a fast spectrum reactor, which is an advanced reactor that lets us capture the enormous amount of energy that's still contained within the rods. If we recycle this way, we could power the US for thousands of years, using just the uranium we've already mined. The leftover fission products can be converted into a stable glass form to be safely stored underground.
This is aluminosilicate and glass. It's a very durable waste form. So this then would be loaded into waste containers and placed in a repository.
In that repository, the glass only needs to be stored for 500 years, which is much less than the hundreds of thousands of years for untreated fuel. Replicate and repeat as needed, and you have nuclear reprocessing. Right now, Argonne scientists are doing research at the pilot facility to figure out ways to optimize the process. And since the best way to improve any process is to know it backwards and forwards, we're working on understanding its molecular chemistry.
We're trying to get the fundamentals of these salts, see when they transition, what happens when they transition.
Their work will help make pyroprocessing more affordable and more practical for potential use in nuclear power plants across America and around the world. So what is it that those Argonne nuclear scientists and engineers do all day? They're working to improve our nation's energy security, keep our electric bills low, and protect our environment.